Hello and welcome to the section 9.2 lecture today. Today we're going to be talking about solving systems of equations by substitution. So yesterday we talked about graphing two equations and seeing where those lines crossed. And today we're going to use what we call the substitution method. And the basics of it are this. Solve one equation. Plug it in to the other. Okay. So basically what we're going to be doing is solving one of the equations for one of the variables and saying that since, let's say we solve it for x, saying that since x equals some expression in terms of y, when we put that in for x into the other equation, we're kind of setting that as the same value, solving for y, and then in the end, we're going to solve for x. So let's go ahead and take a look at it, though. In this first one, we have an equation that's already solved for a variable. And this bottom equation is already solved for x equals 3. And so really what we're doing here is we're saying, all right, I want to come up with a t-chart, an x and a y. And when you do this in lines, you just pick random x's. Well, at some point today, we're going to have something like maybe x equals 2y minus 5. And we're going to figure out what y is based on that. And then once we figure out what y is, we can then backfill and plug that number in for y and figure out what x is. And so on this one, we have, x equals 3. And so let's find out what y is when x is equal to 3. And that's also going to give us what the other value is because of this one being solved so drastically that it equals 3. So let's go ahead and see. 4 times 3 plus 6y is equal to negative 24. 4 times 3 is 12. And if I subtract 12 from both sides, I get 6y equals negative 36. And when I divide by 6, I get y is equal to negative 6. So for this line, for this one right here, when x is equal to 3, y is equal to negative 6. Most of the time, that would just be random guessing as far as, well, let's just pick an x and figure out what y is. In this case, since the other line, we know that x equals 3, then really what we have here is we have some kind of a line. Let me kind of graph it right. Okay, so we've got one line that kind of goes like this, and another line that goes like this. This one happens to be x equals 3. This one happens to be 4x plus 6y equals negative 24. And these two lines end up crossing down here at 3, negative 6. That just happens to be the case on this one. So anyways, on any substitution problem, once I find out what y is, that's like a sub-answer. And usually I'd have to go back and figure out what x is, but it tells me. So my answer is 3, negative 6. That's where those two lines cross. And I want us to keep that in mind when we think about systems of equations. We're looking for the point where the two lines cross. So let's go ahead and look at another one. On this one, I have both of them solved for y, which is kind of weird. But what I'm going to do is I'm going to take this expression for y, this x expression for y, and plug it in to the other equation right up here. And I'm going to put it in for this y. So now my new equation is going to look like 4x plus 14 equals negative 2x minus 4. And a special thing has now happened. I don't have any more y's. All right, I'm out of y's. My equation only has x's. And when an equation in math only has one variable, most of the time we want to solve that thing. So I'm going to add 2x to both sides. I'm also going to subtract 14. and do these problems here. I got 6x. My 14's cancel, my 2x's cancel, and I get negative 18 over here. When I divide by 6, I get x is equal to negative 3. I'm halfway done right now. I have one answer. I kind of need two, because right now I only know that the x-coordinate of where these two lines cross is negative 3. I also need to know the y-coordinate. And so pick whichever equation you think works best. I'm going to pick the top one. And I'm going to put negative 3 in for x. Negative 2, negative 3, minus 4. Negative 2 times negative 3 is going to be positive 6, and positive 6 minus 4 is going to give me y equals 2. And so that's another half answer. Bringing both those two together, I get negative 3, positive 2 is where these two lines cross. Okay. On the next one, I already have one equation solved for y, and I'm going to use that. I'm going to put this thing into this equation for y. So it's going to start off looking a little bit ugly because I have 5x minus negative 3x minus 18 equals negative 22. I will say when you're doing substitution, this part is the most commonly missed part, and it's almost the most important, but everybody gets so excited, hey, I substituted, I put that in there, that's great. But you got to remember, keep writing what you have left. Don't peter out once you substitute and say, well, I guess I'm good, I substituted. Write the rest of the equation, otherwise it doesn't make sense. So I'm going to distribute a negative, kind of distribute a negative 1. It's just going to switch the signs of both things in the parentheses. E equals negative 22. 3x and 5x is 8x plus 18 is equal to negative 22. Subtract 18 from both sides. And that looks like that side's going to be negative 40. And we'll divide by 8 to give us x is equal to negative 5. So I know the x-coordinate of where they cross. I kind of usually give myself some kind of indication that that's part of an answer. I need the other half, though. So we're going to plug in negative 5 into this equation. Now, I will say a big advantage, and most of you probably have solved systems of equations in multiple ways in the past. A big advantage to substitution is that if you do it right, this last part definitely is easier because I have an equation already solved for the variable that I'm missing. So this is just a calculation problem now. It's not really a solving equations problem because I don't have to move anything to the other side of that equal sign. I get y is equal to negative 3. So these two lines cross at negative 5, negative 3. We're going to learn tomorrow about another method called elimination, and there's a trade-off between the two, and I'll talk a little bit more about those tomorrow. But in substitution, the harder part is right here. This is the hard part, right? That you've got a lot of stuff that you're dealing with. You got to simplify a side of the equation and then solve an equation. But then the other side, the finding the second variable, is a little bit easier. And that's going to be a trade-off that we talk about tomorrow. So kind of a step-by-step process now that we've seen a couple. We haven't had to do all these steps every time, but they are valid steps. First of all, we're going to solve one of the equations for one of its variables. Substitute the expression from step 1 into the other equation and solve for the other variable. Substitute the value from step 2 into the revised equation from step 1. So that's saying once you get, say, x equals negative 5, plug that back into the equation that you used to kind of actually get step 2 started. Plug it back into that value, into that variable, and solve what you have left. They do say to check your solution. That would just be saying, all right, if I put -5 in for x and -3 in for y, check it in both equations. Does 5 times -5 minus -3 equal -22? And this would be -25. This would be +3. -25 plus 3 is -22. And then check it in the other equation also. Okay. But those are just the quick 4 steps to doing substitution. This is a big. I love these little quick keys here. Okay. Anyways, next one. It's asking, is it easier to substitute or graph? And really, when it comes down to it, I would say it's all based on the difficulty of the equations. Now, granted, this one doesn't have anything set up. This is kind of a hard problem when it comes to substitution because I don't have any equation that says x equals some stuff or y equals some stuff. That's kind of the marquee of knowing that I want to use substitution, is if I have one of these two types of equations, and this has neither. So I'd actually have to take maybe x plus y is equal to 5 and do step 1 in this graphic here that I haven't done yet, and that is to solve one of the equations for one of its variables. And so I'm going to mix it up a little bit. I'm actually going to solve it for x. I'm going to subtract y on both sides. And so this is kind of like I said, the hardest type of problem for substitution because I'm not even ready to substitute yet. But with just subtracting y on both sides, now I am. I have x is equal to 5 minus y, and I'm going to plug that in for x in the other equation. That's the important thing, is that I don't try to plug it back into my original equation, because that's not going to give me a whole lot. It's going to give me something like 0 equals 0 or 5 equals 5 in this case. So that's not really going to give me anything. I need to plug it into the other one. So let's go ahead and do that. So now I have -5 times this whole quantity, 5 minus y, minus 7y is equal to -21. And again, my equation now only has one variable, so I can go ahead and solve it. I'm going to start off with distributive property. -25 plus 5y minus 7y equals -21. When I combine my like terms, I get -2y equals -21, -25 in front. I'll add 25, and I'll get -2y, running out of room here. -2y is equal to +4. So when I divide by -2, I get y is equal to -2. Okay. So here I get y is equal to -2, and I need to find out what x is. I'll find out what x is using this revised equation, as the graphic up above says. But this is going to be, one of my answers, or half of my answer. So now I'm going to say that x equals 5 minus -2. When I plug things in, I like to put them in parentheses so I know that that's what I'm plugging in. And if I make a mistake, I can always go back and look where I did that and see if everything's good. So here I get x is equal to 7. So we get these two lines intersect at 7, -2. And that was kind of a harder problem. But if I look at the graphing side of things, if I try to graph this, I get an x-intercept of 5, a y-intercept of 5 and an x-intercept of 5. So these two lines cross right here, or sorry, not two lines, but this one line crosses the x-axis and y-axis right here. And now I need to graph that line. Just going to do my best at trying to graph it. And keep in mind, I'm using all the tools at my disposal. I'm using a straight line tool, using the cover-up method, all those things. Let's look at the other one. When I cover up x, I get negative 7y equals negative 21, which is going to give me a y-intercept of 3. And when I cover up y, I'm going to get an x-intercept of, it looks like negative 5 equals negative 5x equals negative 21. So that's going to be like 4 and 1/5, 4.2. That's going to be somewhere in here. Maybe a little bit bigger, right? Not too much though. So when I graph this one this way, I need 4.2. That's probably somewhere in there. Probably about there, I guess. And again, just doing my best with a straight line and graphing using the cover-up method. And we see that it's kind of close, but it's tough to tell. And this is kind of the issue that we run into when we're using the cover-up method, that I got an ugly x-intercept on that bottom equation. But we can see that it's getting close, right? My algebraic method said that they intersect right here at 7, negative 2. And I would say that's close, right? But I was definitely stretching it, trying to get it there. And so that kind of brings me to the big thing about substitution is it makes life easy in that it's always going to give you an answer. It's algebra based. It's not visual based. It's not graphing ability based. So that's what makes it a little bit better. Let's look at some more of these examples, try to get through them a little bit quickly. And yeah, we've got 6. So let's just go at them. I have what I kind of consider every possible rundown of when we might use substitution. The first one is when I have 2 lines in slope-intercept form. It may be easy to graph this, but if you look at them and look at them critically, they both have some ugly y-intercepts as far as I would need a pretty big graph in order to graph these. So I'm gonna choose substitution so that I don't have to have a huge graph. And I get negative 3x minus 17 is equal to negative 4x minus 22. A lot of negatives here. I'm going to add 4x and add 17. And from that, that's going to make my life really easy and tell me that x is equal to negative 5. That's half of my answer. I can actually use either equation at this point, but I do like the one that I previously substituted in. Negative 3 times negative 5 minus 17. That's going to give me 15 minus 17. Looks like y equals negative 2. So I've got x equals negative 5 and y equals negative 2. Okay. On the next one, I do have an equation that gives me a y equals, so I'll plug that into the other equation. 5x minus 5, 2x minus 4 equals 10. We'll distribute. And combine like terms. Subtract the 20. And divide by negative 5. So that gives me x equals 2. Now that I know x equals 2, I'm going to plug that into the other one. 2 times 2 is 4, and 4 minus 4 is 0. So I get y equals 0. And I get that I'm going a little bit quick through these, but I'm trying to keep the time down a little bit, even though this is a big topic. and we want to be really good at it, I just encourage you to slow down and try these and see all the steps that I'm taking. And this one's going to end up something okay. 4x minus 3x is x, plus 21 equals 21. If I subtract 21 on both sides, I get that x is equal to 0. Now with x equal to 0, y equals 0 minus 7. So y equals negative 7. So I get the point where the two lines cross as 0, negative 7. Go ahead and pause the video and try the 3 down below. Hopefully you had a chance to get that done. Let's go ahead and see how you did. On the first one, we're going to plug negative 7x minus 22 in for y. This one's a little bit ugly. Negative 7x minus 22 equals negative 13. A lot of negatives going on. And not only that, but when I distribute, I get 56x. And just to double check, 8 times 22, 176, which I would be concerned with such a big number, but I do have a big x value that I'm looking at. So I'm not too concerned yet. That's going to give me a 49x. And if I subtract 176 from negative 13, that is really 13 plus 176, 189. And now I'm going to divide that by 49. I'll write in the steps. Oops. Wrong way. I will write in the steps. 189. That's not right. Hold on. It shouldn't be that ugly. Yeah, I wasn't too mean, I didn't think. Let me make sure I can see what I'm doing. I'm subtracting 176 from negative 13. 176, 189 divided by 49. Is it really? Yeah, that's right. Just checking all of them. Yeah, 56, so 49. Yeah, okay. Guess we're stuck with something ugly. Did I miss a negative? Yes, I did. Okay. I actually added a negative in there. If I don't fix it, I'm never going to hear the end of it. So that's negative 56. And so we've got 63, negative 63x. So 189 divided by 63. That works out a little bit better, and that's kind of what I thought. I tried to keep the answers somewhat vanilla. So if you get something crazy, just double check it. Again, I tried to be kind of nice. What I say, 189. And when I divide by 63, I get x equals 3. Okay, sorry about that. Then we get y equals 7 times 3. So again, I'm using this top equation. 7 times 3 minus 22. And my pen's going to choose now to lag out. That's good. That's going to be 21 minus 22, which is going to be negative 1. So I get 3, negative 1. Thankfully, after kind of a tough one, they give us an easy one. Negative 3x plus 2 times negative 8. Not only is this equation solved for a variable, but it's already equal to a number. Negative 3x minus 16 equals negative 7. Add 16 to both sides. That's going to give me positive 9. And so x is going to be negative 3. So I get x is negative 3, and I already knew that y was negative 8. Okay. Last one here. I need to choose one equation to solve for one of the variables. I'm going to choose this one, and I'm going to solve it for y. All that's going to take is to add 3x to both sides. And so I get that y is equal to 3x, excuse me, plus 6. Plug that in for y. A lot of multiples of 3 here. There are a lot. Negative 6x plus 9x plus 18 is equal to 9. Combining like terms, I get 3x plus 18 is equal to 9. If I subtract 18 from both sides, I get 3x equals negative 9. And just as I kind of suspected, my answer is a multiple of 3. So I get x is equal to negative 3. And now I'm going to put that into my kind of modified equation here. Y equals 3 times negative 3 plus 6. 3 times negative 3 is negative 9. And negative 9 plus 6 is going to give me y equals negative 3. It's okay to get the same answer for x and y. Just trust it. All right? If you have any questions, make sure they go over on the left-hand side. Otherwise, I hope you have a great day, and we will see you in class.